In this video, we are going to see how semiconductors are used in automobiles. Introduction. The integration of semiconductors into automobiles has revolutionized the automotive industry, ushering in an era of innovation and advancement. Semiconductors, with their unique electrical properties, have become essential components in virtually every aspect of modern vehicles, from engine management to safety systems to entertainment features. This integration has not only enhanced vehicle performance and safety but also paved the way for the development of electric and autonomous vehicles. In this analysis, we will delve into the myriad ways semiconductors are utilized in automobiles, examining their roles in engine control, safety systems, infotainment, advanced driver assistance systems, electrical and hybrid vehicles, and diagnostic systems, etc. Semiconductors serve as the backbone of the modern automotive industry, driving unprecedented levels of performance, safety, and connectivity. With the increasing complexity of vehicle systems and the demand for smarter, more efficient vehicles, semiconductors have emerged as indispensable components in automotive design and engineering. This analysis will explore more about the multifaceted role of semiconductors in automobiles. Additionally, we will examine how semiconductors are shaping the future of mobility, particularly with the rise of electrical vehicles and the transition towards sustainable transportation solutions. By examining the pervasive influence of semiconductors in every aspect of automobile design and functionality, we gain a deeper appreciation for their transformative impact on the way we drive, interact with vehicles, and envision the future of transportation. Semiconductors have fundamentally transformed the automotive industry, ushering in an era of unprecedented innovation. In this analysis, we will delve into deeper the specific semiconductor technologies and the communication modules. We will explore more how these technologies enable precise engine control, real-time monitoring of vehicle dynamics, etc. Furthermore, we will discuss the challenges and opportunity associated with the increasing integration of semiconductors in automobiles, including concerns about cybersecurity, supply chain resilience, and the quest for greater energy efficiency. By examining these complexities, we can gain valuable insights into the ongoing convergence of automotive and semiconductor technologies and their profound implications for the future. What are semiconductors? Semiconductors are materials that have properties between those of conductors and insulators. They are used extensively in electronic devices because their conductivity can be controlled and modified, making them essential components in the manufacturing of microchips, transistors, and diodes. Semiconductors have a unique property where their conductivity can be altered by factors such as temperature, light, or voltage, etc. This property allows them to be used in various electronic applications, including amplification, switching, and rectification, etc. Silicon is the most commonly used semiconductor material, but other materials like germanium and gallium arsenide are also used in certain applications. Classification of semiconductors. Semiconductors can be classified as follows, like intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor, also referred to as pure or undoped or flawless crystals free of other elements, flaws, and impurities. All semiconductor materials, including those doped with other components, have intrinsic features, with the doping components introducing other desired qualities. Extrinsic semiconductors, or the conductivity of the semiconductors, can be improved with the help of smaller number of suitable atoms known as the impurity. The process that involves adding impurities to the pure semiconductor is called doping. Generally, one atom in 107 will be replaced by a dopant atom in a doped semiconductor. Properties of semiconductor. Electrical properties can be indicated by resistivity. Conductors such as gold, silver, and copper have low resistance and conduct electricity easily. Insulators such as rubber, glass, ceramics have high resistance and are difficult for electricity to pass through. Semiconductors have properties somewhere between these two. Their resistivity might change according to the temperature. For example, at a low temperature, almost no electricity passes through them, but when the temperature rises, electricity passes through them easily. Semiconductors containing almost no impurities conduct almost no electricity, but when some examples elements are added to semiconductors, means electricity passes through them easily. Semiconductors comprising a single element are called elemental semiconductors, including the famous semiconductor material silicon. On the other hand, semiconductors made up of two or more components are called compound semiconductors and are used in semiconductor lasers, light emitting diodes, etc. At 0 Kelvin, semiconductors behave as insulators. As the temperature is increased, it works as a conductor. The conductivity of the semiconductor increases when the impurities are added. The process of adding impurities to the semiconductors is called doping. Types of semiconductors. Semiconductor devices are devices that work according to the principles of semiconductors. There are a wide variety of these devices that can be included in common electronic components. These include laser diode, light emitting diode, photocells, phototransistors, bipolar transistors, insulated gate bipolar transistors, photocouplers, resistors, field effect transistors, Hall effect sensors, etc. This image shows the types of semiconductor devices. Semiconductors in automobiles. Semiconductors in car industry. First one is semiconductors in car industry. Essentially, cars are increasingly becoming computers on wheels. They now include such elements as heads-up displays, autonomous driving aids, sensors, cell phone and communication integration, and high-performance elements in their engines. This is possible thanks to semiconductors, which are driving innovation in vehicle advancement. Although the semiconductors used in vehicles represent a small percent of the total semiconductor produced, they comply with the specific technical and qualitative requirements. The basis for the suitability of a particular semiconductor in a motor vehicle application is informed by application specific system definitions and manufacturing consistency. Quality requirements are high. Vehicle electrification. Semiconductors have made it possible to replace manual system with electrical systems. Nowadays, electrical vehicles are more as compared to normal vehicles. Safety and driver resistance. The increasing need for better safety and driver resistance systems in cars has provided a niche for semiconductors. Connectivity. Cars are increasingly incorporating technology that improves their connectivity. New vehicles on the market include ever more and sophisticated telematics and infotainment capabilities, which feed drivers information on factors such as road closures, collision avoidance, and even free parking spaces at their destination. Semiconductors in 5G. Still a relatively new product, speed, ultra low latency, and reliability means that the revenue potential of 5G is enormous, and demand for smartphones that come equipped with 5G will surge. Not only will this increase opportunity for semiconductor, there are further research and development opportunities to continue adapting the product for even better performance both in and outside of smartphones. These include developments in infotainment, fixed wireless access, always connected tablets, and PC, and more. It is safe to say 5G and semiconductors are critical now and will remain so in the very near future. Browse the common jobs we currently recruiting for. Semiconductors and healthcare, from health tracking wearable devices to blood pressure monitors, pacemakers, and next generation medical devices. Semiconductors have seemingly endless application to health and healthcare. The future of these chips within the healthcare sector may involve assisting the development of devices that are smaller, lower power, but with higher speed declaration. Whatever the future, it's clear that it will not only be exciting but will play an active part in saving lives. Semiconductors and consumer electronics. Smartphones and wearable devices have already been touched on, yet semiconductors are also utilized in VR, laptops, computer, television, and more. Demand for faster and better electrons means that there is a lot of opportunity for talented people who thrive in fast-paced environment, particularly those with experience in research and development. Semiconductor and the automotive sector. The automotive sector is indeed a hotspot for technology innovation at the moment. From automation to information and safety, there are seemingly endless avenues to take and impressive revenue to be made. Brands that weren't previously associated with the automotive industry are connecting now, and that customer demand for smart technology is so high. Those previously working on product created Panasonic, Samsung, and more now have another progression route to consider. Semiconductors in agriculture. In today's world, semiconductors have found their way into smart agriculture and precision agriculture, helping farmers make the right decision on soil moisture, temperature, crop growth patterns, and pest infestations with real-time data from the sensors, detectors, etc. IoT devices such as weather stations, irrigation controllers, and livestock monitoring systems are essential in precision farming. These devices incorporate semiconductors to connect to the internet, collect data, and enable remote monitoring and control of farming operations. Applications of semiconductors. Semiconductors play a crucial role in modern automobiles, enabling various functions ranging from engine control, safety features to infotainment systems. There are many applications, and here are few. Engine control. Semiconductor components such as microcontrollers and sensors are integral to managing the engine's performance, fuel efficiency, and emission controls. They ensure precise timing, fuel injection, and ignition system operation. The next application is safety systems. Semiconductor power advanced safety features like anti-knocking braking systems, traction control, electronic stability control, etc. Infotainment and connectivity. In car entertainment system, navigation and connectivity features heavily rely on semiconductors. From touchscreen displays to audio processing units and wireless communication modules, semiconductors enable a seamless user experience. Electrical vehicles. With the rise of electric vehicles, semiconductors are even more critical. Power electronics, battery management system, motor controllers, and charging infrastructure all rely on semiconductor technology for efficient operation. Advanced driver assistance systems. Semiconductors power ADAS functionalities such as adaptive cruise control, lane departure warning, and automatic emergency braking. These systems used as a combination of sensors, processors, and actuators to enhance driving safety. Telematics. Semiconductors enable telematics systems that provide vehicle tracking, remote diagnostic, and connectivity services. These systems utilize GPS, cellular, and Wi-Fi technology to communicate with external networks and services. Efficiency and performance optimization. Semiconductors enable sophisticated engine management system that continuously monitor and adjust various parameters like fuel injection, timing, air fuel mixture, and ignition timing. Diagnostic capabilities. Modern vehicles are equipped with onboard diagnostic systems that rely on semiconductor-based sensors and processors to monitor the health of various components. Autonomous driving. As the automotive industry moves towards autonomous driving technology, semiconductors are at the forefront of enabling this transition. Advanced processors, sensors, and artificial intelligence algorithms are essential components. Environmental impact. Semiconductors contribute to reducing the environmental footprint of automobiles by enabling the development of more efficient electrical hybrid vehicles. Supply chain challenges. The increasing complexity and reliance on semiconductor technology in automobiles have also brought about supply chain challenges. Shortages of disruptions in the semiconductor supply can significantly impact automotive production at business in recent years. Future innovation. Semiconductor continue to drive innovation in the automotive industry with ongoing research and development focused on areas such as vehicle to everything, communication, augmented reality, dashboards, and advanced sensor technologies. These innovations promise to enhance safety, convenience, etc. Semiconductors have dispersed applications across various fields, including electronics, solar cells, LEDs, etc. Electronic semiconductors form the backbone of modern electronics, powering devices like transistors, diodes, and integrated circuits. So in solar cells, photovoltaic cells, commonly known as solar cells, utilize semiconductors to convert sunlight into electricity. This renewable energy source is increasingly important for sustainable power generation. LED semiconductors play a crucial role in LED technology, which is used for lighting application in homes, offices, street lights, and displays. LEDs are more efficient and long-lasting compared to traditional incandescent or fluorescent lamps. Conclusion. Semiconductors have revolutionized the automotive industry, transforming vehicles into highly sophisticated and efficient machines. From engine control, safety systems to infotainment and connectivity features, semiconductors power almost every aspect of modern automobiles. They enable improved performance, enhanced safety, reduce environmental impact, and pave the way for future innovations such as autonomous driving. However, the increased reliance on semiconductor technology also brings challenges, particularly concerning supply chain disruptions. Nevertheless, semiconductors remain indispensable in shaping the present and future of automobile transportation, driving continuous advancements in efficiency, safety, and overall driving experiences. Thank you.